Hi, good evening, doctor and my fellow friends. We are from Group 6 and we would like to present our project, which the title is Water Delivery System Design. So this is my group members, Hui Ling, Zihui, me, Jasmine, and Lakshmi. So this is the table of contents and we will talk about project background, design diagram, cost analysis, conclusion, and reference. So for this part, I will talk about project background. Okay, so for the introduction for water delivery system, first we talk about main objective is build a water delivery system for a leisure area located 3 miles from the primary water pipeline. Then the next one is facilities, includes a 40 feet times 50 feet times 4.3 feet swimming pool and 30 hostel rooms with a space for 5 person each. Next, design factors consider valve, pump, and tank locations, pipe sizes, lengths, and specifications. Then, overall goal is to develop a well thought out water distribution system to ensure consistent and clean water supply to the leisure area. Then for the problem statement is designing a reliable water delivery system is crucial for the recreational area located 3 miles from the main pipeline to ensure a steady water flow to 30 hostel unit and the swimming pool, addressing logistical challenges and considering the complexities of growing populations and environmental concerns. Objective: First, design a technically optimized system to provide a consistent water supply to the swimming pool and 30 hostel units. The second one, develop a water delivery system that is both cost-effective and able to meet the demand for water while keeping costs down. Then, apply fluid mechanics principles to the construction of imaginative and successful system. Scopes. For the first one is creating an efficient water delivery system for a recreational area with 30 hostel unit and a swimming pool, accounting for a 3 miles distance from the main water pipeline and ensuring economic viability. Secondly, the system strategically places block valves to control the main water flow to the storage tank and ball valves for the distributing water to the swimming pool. Next is utilize HDPE pipes for the main system and PVC pipes for the swimming pool in different sections of the pipeline. Lastly, two pipes suction and discharge improve the system, addressing water supply challenges in the recreation area.
This is the schematic diagram for this project. Starts with the water supply tank. A total length of 15,839.1 feet PVC pipe with a diameter of 4 inches is attached to it. The pipe begins with a well-rounded entrance, two 90-degree elbow, continue with the globe valve, and the pipe ends with sharp edge at water storage tank for that area. The water storage tank has a size of 43.4 times 55 times 1.6 feet. From the water storage tank, there is two pipe, one connecting to the swimming pool, another one connecting to the hostel. Swimming pool with a size of 40 times 25 times 4.3 feet is connected from water storage tank by polyethylene pipe with diameter of 4 inches for 300 feet with the ball valve in between. The total pipe length from water storage tank and residential unit is 136 feet with the globe valve. Centrifugal pump connected to the storage tank of the hostel at 130 feet height.
This is the flow design from main water supply to the water storage tank. The total length from water supply tank to water storage tank is 3 miles, which is 15839.1 feet. From the design of water main supply to the water storage tank, the PVC pressure pipe is using because it's able to withstand the high pressure application such as the main water supply in the industry process. The high pressure also can ensure their efficiency and durable water supply to the residential and commercial. Moreover, the pipe also is lightweight, which can make handling and transportation simpler in the plumbing and construction sector, where working with heavy items may be difficult, and this function is extremely helpful. Next, the pipe also is durable. It can immune to the corrosion, chemical breakdown, and deal with range of environmental conditions, and this is qualified for using in plumbing system. Curved path is used between the main water pipeline and storage tank because it can control and regulate the water flow in the plumbing application where the flow need to adjust regularly. It also can controlling the pressure. The valve allow flow from the pump to fill the tank and then close when it achieves the desired pressure. The working principle of the glove valve is when a disc is fully lowered, the fluid flow is shut off and vice versa. The conversion unit is made, which is 28.317 liter equals to 7.4805 gallon. The average water consumed per person per day in Malaysia is 205 liter. Hostel is in 30 unit with 5 person per unit. The demand of water used per day is the 30 unit the hostel time with the 5 person per unit time with the average consumed per person per day, which is 3070 liter, and convert it to the gallon. The dimension of the swimming pool we use the length is 40 feet, width is 15 feet, depth is 4.3 feet. And the water used by the swimming pool is the length times width times depth, which is 2580 feet cube, and we convert it to the gallon. So the total water needed per day is the total demand of water used per day plus with the water used by swimming pool. This is the calculation from main water supply to water storage tank. The length from the main water pipeline to the water storage tank is 3 miles, which is 1583.1 feet. Where the flow rate we get is the total flow rate is 27422.92 gallon per day. So we convert it to the feet cube per second. The diameter we assume in the PVC pressure pipe from the main water supply to the water storage tank is using 4 inch and convert it to the feet. So with the radius we got, we can calculate for area. Area equals to pi r square. And with the area we got and the flow rate we got, we can calculate for the velocity where the flow rate is equals to Q equals to AV. The equilibrium roughness of the PVC pressure pipe is 0.0015 millimeter. At room temperature, we assume it is at 20 degrees Celsius. The kinematic viscosity is 1.004 times 10 to the power of negative 6 meter cube per second from the table of properties of water and convert it to the feet cube per second. The Reynolds number is the velocity times with the diameter over kinematic viscosity. And we get the Reynolds number is 15016, which is greater than 4000, and it is as the turbulent flow. The flow is in turbulent flow. The relative roughness is the epsilon over diameter, and we get is 1.5 times 10 to the power of negative 5. Then with the Reynolds numbers and the relative roundness from the Moody chart we plot, we can get the F is 0.027. With the F we get the total length, the velocity, we can find the major losses in the pipe, which is 4.73. So from our design, we have one entrance with each well-rounded, two elbow 90-degree French, and one glove buff, and one exit with sharp edges. With this time with the V square over 2G, 0.0429 is our minor losses in the pipe.
So this is our residential water system diagram. So start from the water storage from the main supply. These are the underground, 1 meter underground, and these are the valve. And pass through the water storage, we have the pump going up to the storage above the building, which have the height of 130 feet. And for the red pipe is actually the discharge pipe, and the blue part is the supply pipe. The specification of our equipment is first centrifugal pump. The centrifugal pump will be the data of the centrifugal pump for the efficiency and also for the Q or the volumetric flow rate will be provided later. And these are the pipe. The pipe we are choosing is the PVC pipe. Here are the summary of our equipment specification for the water discharge treatment. The first one is the primary treatment, which has raw sewage, screening, commuter, and also this disposal. And then it will go through the primary clarifier and will be going through the aeration tank. And then the sludge will be disposed, and also the water then will be returned to the aeration tank, and the secondary effluent will be added by disinfectant. So our problem is the water is about to be supplied from tank 1 to tank 2 with the height difference of 130 feet. The material used is PVC and water at 27 degrees C, and total length of pipe is 136 feet. So calculate the HP if the pump recommended is centrifugal. So the first one, specification of the water is at 27 degrees C, means that equivalent to 80 degree Fahrenheit. And the total length of the pipe is 136 feet. The diameter of the pipe is 4 inch or equivalent of 0.334 feet. The assumption is V1 is equal to V2. And for the coefficient for the key L, we have the reentrant, which is 0.8, regular flange 90 degree is 1.5, and also this one 1.5, and slightly rounded exit is 1. So here are the domestic water demand per person. So the Q is based on the government data. One person required 180 liter per day per person, which is equivalent to 6.4 feet per day times 5 people times 30 unit. It's equivalent to 960 feet per day, or equivalent to 0.011 feet cube per second. And if converted into gallon per minute, it's equivalent to 5.43 gallon per minute. The Raynaud number for this water is 400, which is laminar flow. So if we want to find the F, it's for the British unit is 16 divided by Raynaud number, which is 0.04. Here are the assumptions that's already mentioned before. Here are the coefficient of roughness for the pipe material, which is PVC, which is 0.000005, and also the physical properties table of water. So since we are taking 27 degrees C for the assumption for the water temperature, which is equivalent to 80 degree Fahrenheit, so these are the data we already attained. These are the calculation. This is the Bernoulli's equation, and this one is the horsepower. So it's equivalent to HP is equivalent to pressure 2 over gamma plus delta Z plus FLV square divided by 2 GD, and so on. So this is the horsepower. So from this equation, we need to calculate and label the graph that already given for the centrifugal pump. So here are the Q. The Q attained is 890 gallon per minute, or equivalent to 1.82 feet cube per second. So the efficiency of the pump is 78%, and the HA is 161.71 feet. So here are the maximum height that can be attained by using the pump. And this is the power needed for the pump to attain this maximum point, which is 23,476 feet pound second per second, or equivalent to 46.9 horsepower.
So for this part, we are going to start with the water storage tank, which has 43.4 feet length and 55 feet wide and also 1.6 feet. And then between the water storage tank and the swimming pool, there is a valve, which is the ball valve, and the diameter of pipe is 4 inches, connecting the water storage tank to swimming pool. And then the pipe we use is polyethylene, which is in green color in this drawing. And the swimming pool is 40 feet in length, 15 feet in wide, and also 4.3 feet in the depth. Okay, so the circle part is the water filtration system, and the main drain, the diameter of the pipe for the water filtration system is 2 inches, and then the dirty water removed by a swimming pool and through the main drain and the skimmer, and then the dirty water is going to the pool pump, and pool pump is connected to the multi-port valve. So the type of valve we choose is multi-port valve in this case, and multi-port valve can connect to various equipment such as filter, drain, and also a heater. And the clean water is going after filtrate is going back to the swimming pool. So this can actually help us to save water. So for the storage tank and the swimming pool, the valve connector is we choose is the ball valve. So why we choose ball valve? Because it is a shut off valve which can be completely shut off if we close it, and it can actually control the water flow into a swimming pool. So when swimming pool is full of water, we can completely shut off by using ball valve, and it will be reopened when the swimming pool water level is very low. So for the water storage tank to the swimming pool, the pipe we use is polyethylene pipe, or you also can say HDPE pipe. So it's the benefits is resistant to corrosion, flexible, and has a long service life. So it comes with leak-free joints, and it is highly adaptable. So it's very suitable in this case, so that it can resist corrosions when it is very long lasting. So type of equipment needed in the swimming pool is pool pump, multi-port valve, sand filter, heater, skimmer, and the main drain. So we move on to swimming pool filtration system. So from the um, the valve we use in this case is multi-port valve. So it is very helpful because it is very helpful when we want to do cleaning or backwash the filter media. So it is called multi-port valve because they have multi-ports inside the valve that can allow water move in various directions. So in the figure in the middle, so you can see that the valve is moving. The valve is connected to the filter and also the pump and also the heater and also the drain. So yeah, and also the pump we use here is pool pump because it is very efficient that can run at different speed rather than a pump running constantly at high speed. So sometimes we doesn't need a very high speed pump in the swimming pool filtration system, so we can be adjust the pump speed. And also the pipe we use in here is PVC because this is a very standard residential swimming pool plumbing. It's a best pick for that. So we choose PVC pipe for, and PVC pipe also highly durable. So swimming pool size, the length is 40, wide is 15, and the depth is 4.3. So we will get the volume of the swimming pool, which is 2,580. So as we know the pool volume, which is the in feet, and then we convert it into gallon, which is 19,299.74 gallon. And then the diameter of the pipe PVC, which we mentioned earlier, is 2 inches or equivalent to 1 over 6 feet. And then the turnover time we choose is 4 hours. So we convert it into minutes, which is equivalent to 240 minutes, so that we can calculate the flow rate inside the swimming pool filtration system. And then the flow rate is equals to capacity divided by turnover time, which is 0.1792 feet cube per second, and also equivalent to 80.12 gallon per minute. So we are going to, so just now we already get our Q, which is 80.12 gallon per minute. So now we need to choose the SAM filter that can cover the 80.12 gallon per minute. So the SAM filter that we choose is 22 inches and giving the mass flow rate of 83.83 gallon per minute, which is satisfied our requirement.
This is the cost analysis calculation. We have calculated costs needed for 2 globe valve, 1 ball valve, 1 centrifugal pump, a polyethylene pipe for 300 feet, PVC pipe for 15,975.1 feet, one well-rounded entrance pipe, and two 90-degree elbow, which in total will cost about 486,842.86 ringgit.
Conclusion: a 3-mile pipeline was developed after calculation-driven engineering revealed a daily water demand of 27,422.92 gallons. Next, volumetric capacity of 19,299.74 gallons. Flow rate of 0.487 feet per second. We have chosen a 4-inch PVC pipe, demonstrating our dedication to the principles of fluid mechanics. Then, the pool's water quality is improved by the multi-port valve for DE and SAN filters. Then, a 36-inch SAN filter with a 40 GPM capacity is incorporated into the pool design to ensure effective water circulation. Lastly, the cost analysis explores the feasibility of our suggested water distribution system from a financial standpoint, aiming to achieve a compromise between affordability and sound technical design. So this is the references